Okay, finding all nth roots. What a pain. So, I've come up with kind of a fast way to do it. The first thing that I want you to do, I want you to find the starting theta when k is equal to 0. And remember, it's the nth root of the radius, and then cosine theta divide n, plus 360 degrees times k divided by n. That's the setup, right? Well, if you take a moment to find the theta when k is equal to 0, so in this case, 270 degrees divided by 5, which, let's see, that should be, it looks like 54, so 54 degrees. And then if you take the time to find the pattern, so 360 divided by 5, because 5 is the n, right? So let's see. That is 72 degrees. Well, this is the pattern. All right. When k is equal to 0, this is 360 times k. When k is 0, 360 times 0 is 0. So for when k is 0, all we have is this. So look at, this is what happens. When k is 0, you have the fifth root of 15 times cosine of 54 degrees plus I sine 54 degrees. All right? Now, when k is equal to 1, and since n is 5, our k's are going to go up to 4. 0, 1, 2, 3, 4. That's 1, 2, 3, 4, 5. All right. When k is equal to 0, well, remember the pattern. We're adding 360 times 1 divided by 5 is 72 degrees. So 54 plus 72 is 126 degrees. And then, now that you know that original and we have our pattern established, the rest of it is easy. You just have to do 126 plus 72, 198. It'd be faster if I use my calculator probably. Fifth root of 15, cosine 270. 198 plus 72 is 270. And then finally, when k is equal to 4, then 270 plus 72, I believe, is 344 degrees. All right, there's your 5 nth roots, just like that. All right, if you need to pause this now instead of having to rewind or whatever, pause it now because I'm going to clear this out and I'm going to go on. Okay, so I'm going to cover more succinctly, I think, what I said a second ago. In my lecture video on Monday, I showed you this, right? This is the setup, which is true. This right here is the setup. The nth root of the radius times cosine theta plus 360k all divided by n, same with sine, 360 or 2 pi. But if you break that down into two separate fractions, theta divided by n plus 360 degrees, or 2 pi k divided by n. It makes it a little bit easier because then you can find two things. You can find your starting theta, and your starting theta is when 360k is when k is equal to 0, because 360 times 0 is 0, and you're just left with that first one. So when k is 0, you have your starting theta, and then when k is 1, you establish a pattern. 360 times 1 is 360. 360 divided by n gives you a number, and then with each new theta, you're tacking on another one of those, because this times 1 is this, then it's that times 2, then that times 3, so forth. All right, so let me show you what I mean. So our starting theta, and by the way, if you don't like dealing with radians, initially you can convert the thetas to radians, and at the very end, just convert them back to thetas by, with your calculator, multiplying the degrees by 1 fraction 180, because it's really 1 pi, but you don't put the pi in the calculator, and that will give you the radians, and you can convert that stuff to radians. Or I'm going to show you with radians. So our starting when k is equal to 0, our theta divide n, so pi fourths divided by 4, I'm just going to multiply numerator and denominator by 1/4, and we get pi 16ths. So right away I know that when k is 0, I have the 4th root of 4 cosine pi 16ths, whoa, that looked like 10, plus I sine I'm having my 16 problems today. All right, so now we have to add 360k divided by n. Okay, so what is 360 divided by 4? Well, so here, let me move this stuff. So our pi divided by 16ths, or if you like doing this first, our initial theta would have been 11.25 degrees. And then our pattern theta is 2 pi, because 360, you could think of it's the same as 2 pi. 2 pi oh, did I lock that? I did that. 2 pi divided by 4 is pi halves, or 360 divided by 4 is 90. And I'm going to stick with the pi halves. So I just need to remember that that's 16. So when k is equal to 1, it's the 4th root of the radius, which is 4, cosine. Now on your calculator, well, look at, since I have the 16ths in the denominator, pi halves is the same as 8 pi 16. Well, 1 plus 8 is 9 pi 16ths. Finally, a 16 that looks normal. And then when k is equal to 2, all I'm adding is another 8 pi 16ths. So cosine, 8 plus 9 is 17. So 17 pi 16ths plus I sine 17 pi 16ths. So when k is equal to 3, you don't really need that equal sign there. That's weird. You get the 4th root of 4 cosine 25 pi 16ths plus I sine 25 pi 16ths. And then finally, when k is equal to 4, The fourth root of 4 is cosine 8 plus 25 is 33, I believe. (33 pi/16). And the reason I'm fixing this, I'm modeling, so on a test, I need to know that that would say 16 and not 10, even though this is horrible that half of my 16s have looked like 10. Sorry about that. Okay, so my biggest tip for you all is take the original theta and divide it by n. So in this case it was 4, and there's your pi/16. And then find your pattern theta. So 2 pi divided by 4 is pi halves, and since the original theta has 16 in the denominator, rewrite pi halves as 8 pi/16. Because look at, the first theta is pi/16, and then you're going to add 8. So the next one will be 9 pi/16. You're going to add 8. You're going to add 8. And you're going to add 8. You could even do this on the side someplace. And then there are all the thetas that go inside here. I do need to see when k is equal to 0. Okay, I'm going to pause this and then go on. I'm going to show you what to do when you don't have it in this form. Okay, and then finally, when you have it in complex form, complex rectangular form, and you need to find the nth roots, you first need to convert it to polar form, which means you need to have the radius times cosine theta plus there's the I sine theta. So first we're going to find the radius. Well, remember the radius is the square root of a squared plus b squared. So I do that. And then 3/2 squared is 9/4. And then here's the 9/4 again, times, well, root 3 squared is 3. So 9 times 3 plus 27/4. 9 plus 27 is 36/4. 36 divided 4 is 9. The square root of 9 is 3. All right, so now we have our radius. Our radius is 3. And then to find the theta, remember the theta is inverse tangent b divided a. So 3 root 3 over 2 divided by 3 root 2. Well, 3 root 2 divided by 3 root 2 cancel, so it's inverse tangent of pi thirds. And remember what I said, at all of the pi thirds, so pi thirds, you're going to be 60 degrees or pi thirds. All right, so theta, oh man, I hope I did not lock the rest of these. No, I did not. Okay, so theta is either going to be pi thirds or 60 degrees. All right, so once you've established, that's going to take 3 years. Once you've established what the theta is and what the radius is, there you have what the original setup would be. And you would need to write that. You would need to write this setup. In brackets, 3 in parentheses, cosine pi thirds or 60 degrees, plus I sine pi thirds or 60 degrees, close parentheses, close bracket, to the 1 over whatever that n is, to the 1/5 power. Because we're finding the nth. So the fourth root, the fifth root. Now you need to find the initial theta, right? So when k is equal to 0, we have pi thirds divide 5, or you could do 60 degrees, divide 5. And so we multiply top and bottom by 1/5. So pi 15ths, when k is equal to 0, you're going to have pi 15ths in the parentheses. And then you have to find, or 12 degrees, 60 divided 5 is 12 degrees. Then you have to find the pattern. What are you going to be adding to each new theta? Well, it's 2 pi divided by 5, but remember, since the initial theta is pi 15ths, we want those to have the same denominator, so I'm just going to multiply top and bottom by 3, and that gives me 6 pi 15ths. Or if you want, 360 divided 5 is 72 degrees. So, and that's when k is equal to 1. So I'm going to do it in radians just to model that. So 3, this is when k is equal to 0, cosine pi 15ths plus I sine pi 15ths. All right? And then when k is equal to 1, we have 3. Now pi 15ths plus 6 pi 15ths is 7 pi 15ths. Because we have our pattern. This is our pattern theta that we add each time. And I think I'm going to stop, even though you have to go to 4, I'm just going to go ahead and stop the video because whoops, that's a 3, that's a 4. All right, so 6 plus 7 is 13, and you guys can finish off the rest. All right, so this is how you find the nth roots of things, and hopefully I've made it easier for you all. Good luck.